So let me remind you of some facts about fractions, and then also look at these facts with new eyes and maybe give you a different interpretation of fractions. So let's start out with revising what we remember about fractions. So the fraction, for example, if you had, let's say, 3/4, so I'd think of a bar. Here's a bar, and I'd break it up into 4 equal pieces, and 3/4 would mean take up 3 out of these 4 pieces. So this would mean 3/4 of the bar. That was the intuitive understanding. Now I want to relate it to division. So what do I mean by relating it to division? So think about division. Let's say I have 8 chocolates and 4 children. Okay, so I have 8 chocolates and I have 4 children. So 8 chocolates, 4 children, and I want to give the 8 chocolates equally to 4 children. So this means that each child will get 8 divided by 4, which is equal to 2 chocolates. Okay. Now, let's think I don't have 8 chocolates, but I only have 3 chocolates. So now I have only 3 chocolates, and the number of children are still 4. So how many will each child get? Well, now I have to think about it. I don't have a full chocolate to give to each children. So let's make 3 chocolates. I have 3 chocolates. 1 chocolate, 2 chocolates, and 3 chocolates. And I want to divide it among 4 kids. So let me do that. I'm going to break up each chocolate into 4 equal pieces. These are the same chocolate, so the pieces ought to be the same. So I have now 12 pieces because each chocolate has 4 pieces. And I want to distribute the chocolates equally among 4 kids. So what I'm going to do is I'm going to take from each piece for each child. Okay, so there's maybe a red child, a blue child, a green child, and a white child. Okay, so for each one of them, I'm going to take a piece from each one of these chocolates, and then I'll do the same for the blue child, and I'll do the same for the green child, and I'll do the same for the white child. So the white child will also get, and this was the green child, so it was the green child. So now you can see that each child is getting, let's look at the red child, was the same, 1/4 from here, 1/4 from here, and 1/4 from here. So the child will get 3/4. So please note, when we wanted to divide 3 chocolates among 4 children, the answer ought to have been 3 divided by 4, which we found out is equal to 3/4. Right? That's interesting. That when you want to divide 3 chocolates among 4 children, each child will get 3/4 chocolates. Now you can see how fractions relate to division. In fact, so now let's try 5 chocolates with 4 children. So here are 5 chocolates. 1, 2, 3, 4, and 5 chocolates. And I have 4 children, the usual red and blue and green and yellow children, and I'm going to break up my chocolate into 4 equal pieces. So let's drop it. Let's do it 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And now I'm going to color the pieces so that every child is going to get one piece out of these chocolates, and that is how a fair distribution of these chocolates ought to take place. I'm just coloring all the chocolates, and then I'm going to color the last piece. Okay, so now I'm done. So now each child, let's pick the green child randomly. So the green child will get 5/4. Remember, because each one of this, for example, this is 1/4, and this is a fourth, and this is a fourth, and this is a fourth, and it's a 4 because we are dividing among 4 children. So there are 5/4. So the green child will get 5/4, the yellow child will get 5/4, and so on and so forth, right? So what we've just found out was, what we found out is that 5 divided by 4 is exactly equal to 5/4. So again, it is reinforcing that division interpretation, that it not only works for proper fractions, it also works for improper fractions, meaning when the chocolates are more than the children. But now, please, which we can write as 1/4. Now, I just want to remind you of a simple fact that we did. So when we were trying to divide 5 by 4, this is how we did it. We had 5 and 4 was our divisor. So 1 was the quotient. So we got 1 as the remainder, right? So what does it actually mean? What it means is, so this exactly means you give one whole chocolate and you are left with 1 as a remainder. So the 1 remainder chocolate still has to be given to 4 children, which means each child will get a fourth. So this should be 1 plus 1/4, which is equal to 1/4, right? So this is exactly the remainder that we are dividing among 4 children, right? So all of this seems to hold together, and let me let me do another example. Maybe it will help. So let's say now we have 11 chocolates. I won't bore you by drawing 11 chocolates. Let's say you have 11 chocolates and you want to divide it among 4 children. It's not hard to say that the answer is just going to be 11/4. And please note, we can write 11/4 as 8/4, or in fact I'll write it as maybe 2/4 divided by 4 plus 3/4. And when you have 2/4 divided by 4, well, the answer is certainly going to be equal to 2 whole, because the 4's cancel, or if you have 2/4 and you want to divide among 4 children, you're going to be left with 2, and then 2 plus 3/4. So the answer is going to be 2 whole 3/4. Now see how the division algorithm does exactly the same thing. So you have 11 and you want to divide it among 4 children. Well, you can give 2 chocolates to each child, and this is exactly the same 2 that we have over here. So if you give 2 chocolates to each child, you're going to be giving away 8 chocolates. You're going to be left with 3, and this is exactly this 3 and this 3 and this 3 and this 3. They're all the same. So then the total answer has to be equal to, so this implies that 11 divided by 4 can be written as 2 whole and 3/4, right? Because if you have 3 chocolates and you want to give it to 4 children, then each child will get 3/4. That's something that we have already done. So that's why it is 2 whole and 3/4. And that's the so hopefully you should be able to see that division and fractions are very, in fact, they're the same thing, just written out in different ways. You should also appreciate how the remainder So when we write the division operator, right, so it actually can mean two things. So this is kind of interesting that, for example, 11 divided by 4 can have 2 as a quotient and a remainder as 3. So this is when you're only doing division in whole numbers. But this is it's very closely related to when you want to fully divide by 4, and then the remainder that you have here, 3, gets divided among 4 children so that each child gets 3/4. So hopefully this should all be clear to you now. Thank you.